Circular singly linked list. In a circular singly linked list, the last node of the list contains a pointer to the first node of the list, which means the last node's next field will be holding the address of the start node of the list. We can have when it comes to circular linked list, there are again two types, circular singly linked list as well as circular doubly linked list. In this video, let us discuss the circular singly linked list. Here in circular singly linked list, we traverse until we reach the same node where we started, and in circular singly linked list, it has no beginning and also it has no ending, and also there is no null pointer as well. And here to form a circular chain of nodes, the last node would be connected with the first node, and this is the representation of circular singly linked list. If you check here, the last node's next field is having the address of the start node, so that the circular structure can be formed. To form a circular chain of the nodes, these two are connected and there is no beginning and there is no ending over here. And when it comes to the key properties of circular singly linked list, the very first one is circular nature. In the next, here in circular singly linked list, the next reference of the last node in the list would be pointing back to the start node, which is the first node, creating a circular structure. Second property is traversal. Here you can traverse the entire list starting from any node and eventually you will return to the starting node. And third property is there is no null reference. Unlike a regular singly linked list, here in circular singly linked list, there are no null references in the next pointer of the nodes, except in the case of an empty list. Only if the list is empty, it would be having the null pointer in the next field. Otherwise, there won't be any null references in the next field of any of the nodes here in the circular linked list. And as usual, when it comes to the operations on the circular singly linked list, again there are two basic operations, insertion and deletion. Let us discuss one by one. Under insertion, again there are four different cases are there. One is performing insertion at the beginning of the list, second one is performing insertion at the end of the list, and third one is performing insertion in the middle. Again under the middle, two different cases are there, performing insertion before a given node and after a given node. Let me discuss each and every cases with the pseudocode. The very first case is performing insertion at the beginning, and let us take this example. This is the existing circular singly linked list, and let us see how to perform insertion at the beginning, which means inserting a new node at the beginning of the existing circular singly linked list. Very first step is create a new node with the two fields, data field and link field. Okay, new node is created and the address of new node is new node only. New node is created now, and the value which you want to insert, for example 25 I want to insert. I want to insert the data element 25 at the beginning of the list, beginning of the circular singly linked list. Let us write the pseudocode. Directly the value can be inserted in the data field of new node, right? So I am going to write in the field of new nodes data field, the value which we want to insert can be inserted. After executing this statement, in the data field of the new node, value 25 would be inserted. Next step is, since I want to insert it over here, what are the changes I am supposed to make? First one is I have to change the start variable. Why? Because after inserting this new node, the new node would become the first node. So always the start variable must hold the address of the starting node. Since the new node is going to act as a starting node after inserting into the list, we have to change the start variable. We have to change the start variable and we have to fill the next field of the new node. This is second step, fill the next field of the new node. And also, since this is a circular linked list, always in a circular linked list, the last node's next field would have the address of the start node. After inserting this new node would become the start node. So the last node's next field must be changed if you want to insert a new node at the beginning. Here the new node's address should come. These three places we have to change now, we have to fill now. Let us write the pseudocode. First, we have to find the last node, because in the circular singly linked list the last node's next field should be changed, right. So, we have to use one pointer, that pointer should point start first. I am using one pointer variable, and the pointer variable would be pointing the start, because to perform traversal I have to use one pointer. With the help of the pointer only we will be able to traverse each and every node, we will be able to access each and every data element. Once we reach the last node, we can stop traversing and change the position of last node's next field. Let us write the pseudocode now for it. We will use condition, we will use while loop, in which the condition is going to be, the task here is to find the last node. Last node's indication is going to be if any of the nodes next field is holding the address of the start node, that is going to be the last node, right. So, the condition here is going to be if the pointer's next field is equal to start, which means if the pointer's next field is holding the address of the start node, that is going to be the last node. Here the condition is going to be, when we are going to keep on incrementing your pointer, when your pointer's next is not equal to start, you keep incrementing the pointer, when it is equal to start you should stop. The condition is pointer's next is not equal to start. Initially my pointer is pointing the start variable, start is dd, so the pointer is going to point the node which has been stored under the memory address dd, because under the start the address dd only has been given. Okay, pointer is pointing start, check whether pointer's next is not equal to start. Yes, pointer's next is not equal to start, start is dd. If I check pointer's next, in the place of pointer's next it is not dd, there is bb there. So, you can now you can increment the pointer. To increment the pointer, write this step, pointer equal to pointer's next. What is pointer's next here? bb. So, in the next step pointer would be pointing the next node which is bb. Now, check again whether pointer's next is equal to start. No, it is not equal to start. We can increment the pointer now. Pointer equal to pointer's next is AA. Now, pointer would be pointing AA. Again check for this condition, pointer's next is not equal to start. Yes, it is not equal to start. You can increment the pointer now. Now, the pointer is pointing the node CC, because in the place of pointer's next only CC was there. So, the pointer has been incremented to the node CC. Check now, check for the condition whether pointer's next is not equal to start. No, it is equal to start. Start is dd. Yes, it is equal to start. If it is equal to start, the condition would get violated. Now, the pointer cannot be incremented. So, come out of the loop now. End of loop. We came out of the loop. Now, we can make the changes. We can do the modifications wherever it is required. Now, this position needs to be changed, right. In the pointer's last node's next field must be changed. So, the last node's next field is referred by the variable which is called pointer. Shall we write like this? Pointer's next field, last node's next field should be changed. Last node is referenced by the pointer variable. So, I have written it like pointer's next is equals to, the new node's address should come. Why? Because a new node is going to act as the first node. Write the address of new node, the new node address itself is new node only. So, I have written it like pointer's next equals to new node. After executing this statement, in the place of last node's next field, the address of new node would come. Since there is in the last node's next field address new node is there, this node would no more connected with the node dd. Now, this would get connected with the new node, right. Okay. We connected the last node and the first node. The next step is we have to change the address of the start variable, since this new node is going to act as the first node. So, before we change this address, we are supposed to fill the new node's next field as well. What should come in the place of new node's next field? Which node is going to act as the next node for this new node after inserting it into the list? This node is going to act as the next node for new node, right. Where is this node's address? This node's address is dd. This dd is stored in start. So, in the place of new node's next, since dd is stored under the start variable, we can write like this. In the place of new nodes next, start should come. Under start, which address is specified? Address DD is specified. So, and the field in the place of new nodes next field, address DD would come. Since I have written the address DD here, now this node, the new node would get connected with DD only. What is the next step? Change in the address of the start node, because this new node is going to act as a start node, where the address of this new node would get stored. Since this is the first node, this node's address should get stored in the start variable, right? Directly it can be written like this: in the place of start, write the address of new node. Under the start variable, we are going to store the address of new node. Now under the start, new node's address would be written. Since I have written new node here, new node, start and DD would no more be connected. New node, start, and this new node only would be connected. Now the complete list is formed, the link is properly framed. Now if you check, proper circular singly linked list has been framed now. Under the start, new node's address is there. So start and new node is connected now, and again the second node of new node is going to be DD, and it follows the sequence till CC. CC is the last node. If you check last node's next field, the start node's address has been given here. The start node is new node. So the last node and the first node is connected here. This is how we are supposed to perform insertion at the beginning in a singly linked list structure. The next operation is, the next case is insertion at the end of the list, which means we are going to perform insertion at the end, inserting new node at the end of the circular singly linked list. The very first task is create a new node. Yes, new node is created with two fields, data field and link field, and the value which I want to insert is 25. Let us write the pseudocode now. And the address of new node is new node only. Now directly we can write that in the place of, we can place in the place of new node's next field, sorry, in the place of new node's data field, data element can be written. The value which I want to insert is 25. In the place of new node's data field, the data element 25 would be inserted. The next step is, we are supposed to fill this field, new node's next field, and in the existing linked list, last node's linked field must be changed, right? These two changes we have to make. Let's check now. And also it can be directly written that in the place of new node's next field, what should come? The address of, since I want to perform insertion at the end, always the last node's next field would be having the address of the start node, right? Shall we write it directly in the place of new node's next field is start? Yes. Let me draw the node here so that it would be easy for you to understand. Create a new node. The address of new node, it's new node only. New node has been created. In the place of new node's data field, write the value I want to insert is 25. In the place of new node's next field, directly we can write start, because it's obvious that always the last node's next field would have the address of the start node. The start node's address has been stored under the start variable, so directly you can write in the place of new node's next field, write address of start. Under start variable, address BB is there, so in the place of new node's next field, address BB would come. Since we have written BB here, this node and the node BB would be directly connected, right? So let's make a connection. Since I have written BB, after processing this node, after processing the new node, it has to move on to the node BB, right? Okay. Now what else are, what are the other operations are pending? Only changing the position of this. Last node's next field must be changed in the in this, because we need to enable the connection between these two nodes, right? If you want to make a connection between these two, this place should have the address of new node. How to change this place directly? We can't come and reach this node CC, right? Always we have to perform, we can access only in a sequential manner in a linked list structure. Unlike an array, we can't directly refer so and so data element with the help of the index here, right? Start from the head, and until you reach this node, you are supposed to keep on performing the traversal operation. Once you reach here, you stop performing the traversal and change this place, change the next field of CC. Let's write the pseudocode for it. Use one pointer to perform traversal operation to reach the last node in the list. Use one pointer, and a pointer should always start from the head node, start node, the beginning node. Created the pointer, pointer is pointing start, start is BB. Now pointer is pointing the node BB. Next step is we are supposed to keep on performing the traversal until we reach the last node. How to identify the last node? If the last node's next field is having the address of the start node, means that we have reached the last node, right? Now the condition inside the loop is going to be if the pointer's next field is not equal to start, we can perform the traversal. If it is equal to start, we have to stop performing the traversal. Check whether pointer's next is not equal to start. Yes, start is BB, pointer's next is not having BB. So we can increment the pointer equal to pointer next. Since it is not equal to start, I am going to increment the pointer. Now pointer is pointing pointer next. Check pointer's next is not equal to start. Yes, pointer next is AA, not BB. Increment the pointer again. Pointer is incremented now. Check for the condition again. Pointer's next is not equal to start. Yes, it is not equal to start. Increment the pointer. Now pointer is pointing CC. Check pointer's next is not equal to start. No, pointer's next is equal to start, which is BB. So the pointer cannot be incremented. Now come out of the loop. After coming out of the loop, now we can change this position, right? Because to refer this node, we have the variable called a pointer. So it can be written like this. In the place of pointer's next, change the address of pointer's next field. In the place of pointer's next, what should come? The address of new node should come, right? Address of new node. New node's address is new node only, so I am writing directly as a new node. Now after executing this statement, in the place of pointer's next, new node address would come. Since the address of new node is there, after processing this node, it is supposed to, after processing this node, it is supposed to, since new node is written, automatically this node and new node would be directly connected. Since new node's address is specified here, the node CC and start node will no more be connected, because in the next field new node only is specified. Automatically this connection would get disabled, and these two are connected. Now if you check, the complete circular singly linked list structure is framed. We have made appropriate changes also. Now you can exit the program, because insertion at the end has been done here. The complete linked list is ready, and this is how we have to perform insertion at the end. And the other two cases are performing insertion in the middle. In the middle again, two different cases, performing insertion before a given node and after a given node. These two are same only, like these two cases are same as that given for a singly linked list. You can refer to the video on singly linked list. Their insertion in the middle has been performed for both the cases, has been discussed before a given node and after a given node has been discussed in insertion in the middle of singly linked list, because the process is same as performing insertion in the middle of a singly linked list. You can refer that video if you have any doubt. Refer the previous video which has been uploaded under singly linked list, performing insertion in the middle. Thank you.